outer space. Out here, what was invisible down below is still invisible to our eyes. But here we can measure it. And by measuring the radiation, infrared, ultraviolet, X-ray, gamma ray, cosmic ray, we can tell the distance of the stars, the energy they are pumping into space, how the atmosphere of other planets is different from our own, the temperature of gases in interstellar space, the strength of magnetic fields, the speed of particles in galaxies. The measurements become numbers, and the numbers are rained down on Earth. And out of the numbers grow pictures. The Earth and its sister planets, the ultraviolet sun, the X-ray sun, radio sounds from space, and the word that there are more than 100 billion stars out there besides the sun. And with each spacecraft, each measurement, we are bringing the universe into sharper and sharper focus, resolving it, seeing it grow brighter and ever clearer in our minds. In a universe of billions of stars, there are billions of mysteries. What is the origin, age, and evolution of the universe, the destiny of the stars and galaxies? We have reached a unique moment in history where man has developed the tools to take scientific measurements that may unlock some of these mysteries. Our satellites will help us crack the secrets of our solar system, unlock the doors in the universe, and enable us to learn more about our own planet Earth. With this knowledge, we may be able to improve life and avoid disaster. Without this knowledge, we may be able to do neither. In the few years we have jumped into space, our image of the Earth's environment has utterly changed. We found, for example, that instead of simply being surrounded by a magnetic field that faded out endlessly in space, we are actually encased in a vast space suit, the magnetosphere. And that this magnetosphere ends at about 40,000 miles. Ends because there's a great wind out there. A wind, mind you, where there is no air, no molecules that you feel pushing against your face when you stand in a breeze. This airless jet stream is the solar wind. And to stand in it unprotected would be like holding radioactive material in your bare hands. You saw our astronauts on the moon unfurl a window shade of metal foil, which they later brought home with them. Man was catching, literally, bits and pieces of the sun, fallout from the sun's nuclear hell. And that is what the solar wind is, fallout from the thermonuclear reaction in the sun. We wanted that sample because we live in a cavity in that wind, and we want to know how it is affecting us when there is a storm on the sun, changing our weather and blacking out our international radio communications completely. And we'll want to know what effect that solar wind has on life. How dependent are we on that magnetosphere? If another planet didn't have this protection, could it still have life as we know it? Or something else we cannot even imagine? There may be only one way to know. Go to the other planets. The inner planets, Mercury, Venus, Earth, and Mars, are relatively small, solid bodies like the Earth. Investigating them is our immediate goal. In 1973, the Earth, Venus, and Mercury will be lined up so that we can try a new way to go further in space. We'll launch our Mariner to Venus, and then use the gravity of that planet like a roller coaster to give more speed and fling it into space toward Mercury. The first time we have ever been able to explore that planet. Venus is a paradox. It rotates the wrong way, for example, the opposite of all the other planets. Or perhaps we are all out of step, except for our lady in space, Venus. Why? Well, we really don't know, but if we find out, it may tell us more about how the solar system was put in motion than all the other planets moving counterclockwise. Venus is the brightest planet, but no one has ever seen it. We have seen the thick reflecting clouds that hide it, but not the planet itself. These clouds heat the planet. Any water on the surface of Venus would immediately boil off into the heavy atmosphere, more like superheated steam than water. Why bother? To satisfy scientists' curiosity? No. No, to know our own atmosphere better, we have to know all atmospheres. We have to ask, how did the Venus atmosphere get that way? Is it possible we are headed that way? Are we mass-producing enough pollution, enough smog, that might trigger the change, upset the balance, change the beneficial effects of our atmosphere? Only to mire ourselves in a malignant envelope that alters our climate drastically, that in the end might extinguish human life entirely. On the other hand, might it be possible for us to reverse conditions on Venus, perhaps with vegetation or chemicals, so that the oxygen locked in the carbon dioxide of the clouds is released, so that the planet cools, rain falls, and it becomes more like Earth? Is it possible that we might seed this bit of matter in space, so that some future generation from Earth can become pioneers in a distant new world? Why not? On Mercury, the nearest planet to the sun, there's probably no hope like that. If this planet ever had an atmosphere, it was blown into space long ago by the pressure of radiation from the sun. Here we may be seeing for the first time a completely desolate planet with no protection from the solar wind. Looking at Mercury, we can ask, is this the way the Earth would be without a magnetosphere or an atmosphere? Lashed by the full force of the solar wind without hope of life. And what about Mars? Well, this is the planet where we hope to find life, or which will help us understand the life process. In 1965, Mariner 4 got our first close-up photographs of Mars. 4 years later, Mariner 6 and 7 returned for a more detailed look. They sent back fascinating pictures of the rugged surface and the polar ice caps. When you watched this on TV, did you really feel that the spacecraft sending back the pictures was actually 60 million miles away? Can you imagine 60 million miles? The next step will be to orbit Mars. This unmanned flight is scheduled for March in 1971. Then we'll colonize it with machines. Our Mayflowers and our Pilgrim Fathers on Mars will be Viking, orbiters and landers. On the way down, the landers will measure the thin atmosphere. While overhead, the orbiters make related measurements. Then, for at least 90 days, our mechanical astronauts will take pictures, analyze the soil, sniff the strange air of Mars, feel for moisture. Thus, we will obtain information about Mars from the ground up to the limits of its atmosphere. Perhaps the greatest interest will be in the lander's search for signs of life. We're pretty certain now that there is no man-like life there, but we were not always men. We were once just cells. Before that, we were perhaps just molecules of protein. And we still want to know if there's that kind of life, or if sometime in the past, life did exist on Mars, and what could have happened to it. All of this will lead up to the ultimate exploration by man himself on Mars. The outer planets, on the other hand, are entirely different from the inner planets. On Jupiter, Saturn, Uranus, and Neptune, there may be no place to land, stand, or walk. They're all several times the size of Earth, but they may not have a solid surface to land on.